Hello everyone, welcome to ChemUp Academy, where chemistry is simplified and success is amplified. So we are continuing with the lecture that is of your conductance unit from UPSC prelims geochemist. So this shall be your lecture number 2. So you can again write the unit. Conductance. It is for prelims and it shall be your lecture number 2. You can find the series here only in the comment section. Also you can find the link, so if you are having any queries, so you can ask regarding to that. Okay, starting with our lecture today. We have certain sort of questions, like this is your question that actually came in the year 2022, and here we have another question. It came in 2023, and another question we have, it is the recent one that came in 2025. So these are basically the PYQs, and after solving the PYQs you would believe in yourself and in my teaching as well that you are able to solve these questions. It means you are well prepared, or you have the gainment of the knowledge, and of course the knowledge for the topic as well. So before actually discussing the topic for today, let me just show you a question. The question says that equivalent conductance of strong electrolytic solution is. In order to answer this particular thing, what I shall be teaching you today is that a new topic, that is the molar conductance that we read yesterday, the molar conductance along with the specific conductivity, that was the kappa. The molar conductance and the kappa relation today we shall be following and observing. On observing the relationship, what we were having was kappa upon my concentration was this. We all know that whenever the kappa is given, it will be Simon centimeter inverse, and in terms of this we have decimeter cube. Therefore, in order to because these units are mismatched, therefore what we can draw a new relation is that kappa upon C into 1000. So this shall be your formula that you shall be observing for the coming new slides or new chapters, or I would say new questions. So regarding to that, we have derived this new formula because of the dimensional units that we were facing before. Now coming on to the topic, the next topic for today is dilution effect. Dilution effect on molarity and on kappa as well. See, questions are being asked every year on the from the dilution effect, from conductance. Of course, the conductance topic is important. Therefore, this topic, this subtopic of the conductance topic is quite more important क्योंकि हर साल questions आते हैं. Okay, the first thing that we have over here is molarity, and here we have the kappa. Kappa, you understand? Kappa is the specific conductivity that we have discussed in the previous lecture, that is lecture number 1 for conductance unit. Now, since we are talking in terms of kappa and conductivity, we know that conductance usually depends on the two factors, that is number of ions, how many ions are there, and another factor that is varying is that mobility of ions. So we have two factors on which the conductance depends. First is the mobility of ions, and another one is the number of ions. So if we talk in terms of dilution effect on kappa, we can say that whenever there is dilution, we can say that whenever there is dilution, the kappa usually decreases. And whenever there is dilution, molarity, the molar volume usually increases. This is the conclusive statement. How can I say that it is decreasing, or how can I say that it is increasing? The basic factors are usually, first of all, when we talk in terms of kappa, we can say that with the effect of dilution, this is the specific per unit volume that we are talking about, since the volume in which the volume that was fixed for one mole to be rotated or for one ion to be rotated was fixed. Now since we have diluted, therefore one mole shall be rotating in the whole of the volume. the fixed volume, because there has been dilution. For specific terms, when we talk in terms of specific terms, and kappa is again a specific term, therefore we can see the decrease. Same volume के लिए एक मोल जब घूम रहा था, therefore the conductance was seen to be decreased as for the kappa. Hence we can say that it is decreasing. Whereas when we come on to the molarity, we can say that on dilution the number of moles. How can we determine the number of moles? The determination of the number of moles could vary, like we have strong electrolyte and one we have weak electrolyte. Say we are taking in terms of strong and we are taking in terms of okay. Strong electrolyte, when we talk for strong electrolyte, we say we have NaCl and complete ionization shall proceed for Na positive and Cl negative, like this. If here 1 mole was there, also this formation shall be 1 mole equivalent amount. Therefore, the number of ions have increased. Now, if we talk for the weaker one, we can say that in case of the weaker one, we have something like, therefore, it shall break like, if it has concentration of this and these have concentrations of alpha, therefore C minus C alpha shall be the thing that we would be getting. This shows the incomplete variation and this shows the complete variation. Therefore, the mobility of ions have been increased. Hence, the factor that is playing role over this is mobility. We can say that since on dilution they're getting larger space. Here it was the term for specific, but here we are talking in terms not for the specific but for the whole as a volume. Therefore, we can say that the molarity can, or the molar conductance usually increases. Hence, we have written or drawn the conclusion saying that it usually increases with respect to dilution. Therefore, I hope this whole topic is clear to you all, and regarding to this, we have one more topic to cover, that is, it says that whenever you have a strong electrolyte, for a strong electrolyte, what shall be observed is this, and another shall be for this. Okay, we have two diagrams. One is showing the regular and it is showing the steep one. Alright, why the sudden change, not steep, we can say the sudden. If we plot molar conductance with concentration, what we can observe is that as the molar conductance increases along with the concentration, we can see that there's a sudden change. There's a sudden change in one slope and another one is showing the regular change, like the regular decrease is there. For this, we can conclude that if sudden change is there and if regular change is there. For sudden change, we can say that they are strong, and for weak change, because on dilution only at certain specific volume there shall be increase in conductivity, therefore we can say that it is for weak one. Like this, we can conclude that these graphs shows the weak one and the sudden one shows the regular one. Regular one shows the strong electrolyte we are talking in terms of, and here we have weak electrolytes. Electrolytes, you understand, strong electrolyte shall be your NaCl, KCl and so on. Whereas for the weak one we have NH4, we have acetic acid we can take. So these are for the weak one and that is for the strong one. This question has directly been asked in your year, I believe 2023. This I have what also. Okay, so this was all about the molar conductance along with the concentration. How can we describe about the concentration and molar conductivity? For describing the concentration and the molar conductivity, we can draw a conclusion And drawing a conclusion refers to, over here we can drawing a conclusion says that molar conductivity depends like this and kappa depends like this. Conclusion 1 and conclusion 2. As the molar conductivity increases, there shall be decrease in the concentration. Also, if kappa increases, there shall be direct proportionality with the concentration. So this has to be marked as important, and this is all about the dilution effect. And coming on to the questions that we can solve right now is, okay, here these are the two graphs that are shown, and this graph is like this. Okay, here we have molar conductivity, here we have concentration. The first graph and the second graph, along with the reference, you need to tell which belongs to what. We know that strong and the steep ones, the strong goes with the regular change, and steep ones, or the sudden ones we can say, goes with the weak electrolytes. Like this we can solve. So this was your for UPSC. Like this the questions are usually asked. This shall be your homework. Everything has been written, everything has been explained completely. So I hope you can answer this question now. Coming on to the next question for today, we have, okay, they are saying that equivalent conductance of the strong electrolytic solution usually decreases with dilution, increases with dilution, doesn't vary and may vary across. See, whenever the equivalent conductance would be there, that means N equivalent conductance would be there. Equivalence usually depends on the normality. Like we have stated, the proportional concentrations along with the molarity for the molar conductivity or for the molar conductance, we have the same topic or the same thing goes for the equivalent conductance as well. Therefore, we can go with the option B, which says that as the dilution increases, the molarity or the molar conductance was increasing on the dilution because of the mobility of the ions was increased, and more the mobility, more will be the conductance. Similarly, coming on to the equivalent concentration, we have more will be the mobility, more shall be the conductance, and more will be the equivalence conductance. Like that only we can solve. So this was your question for 2025. Coming on to the next question. Okay. This question is basically a numerical. So according to this question, let's just read it first. The question says, resistance of normality has been given. So let me just write down what is my normality. Normality is here. Solution of electrolyte occupying a volume between two platinum rods of cell constant. Remember, cell constant we used to write L upon A. That was supposed to be 39 per meter. Also, this was known to be as G dash. Like these were also given. Now coming on to the resistance they have given. Resistance refers to R is equals to 30 ohm. Resistance could also be written as 1 upon C if we remember, or 1 upon G if we remember. Specific conductance and equivalent conductance they are asking. Specific conductance refers to your kappa, and according to our knowledge, we know G dash into 1 upon G is your specific conductance. Therefore, these two values are already given to us. We can directly multiply them, which says that 39 divided by 30. Writing their equations like this and this equation like this. So we can have 39 divided by 30, it can be 10 and 13, that is 1.3 ohm inverse meter inverse. So this solves your specific conductance. That is the first part of the question has been directly solved without without inputting so much of thing. Coming on to the next question, which says that equivalent conductance. Equivalent conductance we all know. Okay, for equivalent conductance, what we can say is that it says equivalent conductance. Let me just solve it for molar conductivity, which was saying that kappa upon concentration has to give us the molar conductivity, and just Now we did the formulation also. If you see the first slide of ours, we just did this. So in order to balance the sciences, we have made this. So just using the same formula, we have kappa upon concentration into 1000, but that is same for the molarity. And here the question is asking us to mention the equivalent conductance. Therefore, an equivalent for now for this question shall be K upon normality. Instead of concentration, we shall be mentioning the normality over here. That has already been provided to us in the question itself. So therefore, we can directly place on the values, and on placing the values, we will get and here again, in order to balance the units, we have kappa was 1.3 upon 1000 into normality is given to as 0.01. On solving this particular thing, we can have it says that 0.13 equivalence. Let's place the units also. On placing the units, we can get here we have unit as normality, normal. For this we have ohm inverse, meter inverse. So we shall be having ohm inverse, meter inverse, normal inverse. Like this refers to your equivalence unit. Instead of an equivalent, you can write it as equivalent as well, equivalent inverse. And hence the question has been solved without giving much input to the questions. So again, revising the topics that we did today. Okay. This was the first relation, that is the relation between kappa and molar conductivity. This we did in yesterday's class as well. Coming on to the next topic, we did the dilution effect. The dilution effect has to be marked as important because every year you can see the questions are coming as we did. Though the questions are not very difficult, but since you have got this thing to tackle and you have got this thing to tackle, therefore you can tackle the questions as well very easily. So this was all about the dilution effect on kappa as well as the molar conductivity. Related to the molar conductivity, we have derived a new formation of the question which could be seen in this particular thing, which says that an equivalent has to be calculated, which we have calculated using this formula, which has come from the molar conductivity index only. So like this we can solve. And coming on to the rest question, this question shall be your homework. You can mark it as homework over there and you need to comment it down. Another question that we did is, yeah, this one. That is again the molar conductance. Again, we can write the formulation for molar conductance, which says that molar conductance is equals to kappa upon normality into 1000. So this, into 1000. This is how you can solve the questions related to conductivity and you can move forward in your preparation. So this was all for today. We shall meet in tomorrow's class again with the same topic. We shall continue with this only. So thank you and keep watching.
ChemUp Academy. Chemistry simplified. Success amplified.